Going on to the last topic of Chapter 3, Section 6, we're dealing with functions. Now, for some of you, this might be new, but for others, not so new. But I want to give some background, and you can take some notes on this, and I should have some of this perhaps on the board. So, we want to know what the word relation, domain, range, and function relate to in this particular section. Now, one of the key words is, are numbers somehow related? Well, if we think of the ordered pair, are the x and y related? Absolutely. These make a point on the rectangular coordinate plane. So, a good example of a relation in mathematics is the ordered pair, and that's why it's included in Chapter 3. Now, in the ordered pair, we have the x element. The x element make up in mathematics what we call the domain. So domain are the x elements in an ordered pair. And as you probably figure, the range are the y elements in the ordered pair. And while we're here, in mathematics, what do we consider a function? Now, many things are a relation, that is, the numbers are linked together somehow, but they're not a function. In order to be a function, a very simple definition is that the x element is only used once in a series of ordered pairs. So again, you want to take some notes on this and use that as you do examples in Topic 6. So let's get started. They're asking us to find the domain and the range of each relation. So I would suggest in your notes you're going to put a D here for domain, use a brace, and now we're just going to list the x elements. So 2, 0, -1, -2. And let's do the range. And this is roster notation. We're just listing them. And since we can change colors, we're just now going to list the x elements. And you can do them right in order. 3, 0, -5, 6. So pretty straightforward. Now for letter B, we're going to do the domain, and in roster notation, 3. Now I see the 3's are repeated. If they are repeated, we only write it once. We don't have to repeat it. And then the range will be 1, -2, 0, 6. Now, let's just use this. We're going to have more examples. Is this series of relations a function? Well, are the x elements used more than once? No, they're only used once. So this is a function. Now, how about here? Is the x element used more than once? Yes. So this is not a function because the x elements are repeated. All right. Now in example 2, we see the series of ordered pairs. We're wondering, we know they are a relation, but are they a function? Well, we have 10, -3, 2, 6. Is the x element repeated? No. So this is a function. Here we have 3, -3, -3. It's repeated. So this is not a function. Now, we have other tests that when we're looking at a graph that can help us out to determine whether something is a function or not. And we'll take a look at this. And for this, we're going to do what is called the vertical line test. And for the vertical line test, we imagine a vertical line that I've drawn in red here that we're going to take over the face of the graph, and as we bring this line over, does it intersect the graph in more than one place? And we see, yes, it's intersecting there in many places, twice. Well, if it intersects more than once, then it is not a function, because the x values are actually repeated. But the easy way, does it intersect more than once? Yes, then it's not a function. We say it has failed the vertical line test by intersecting more than once. Now, how about that vertical line here? Does it only intersect once as it moves across this negative slope? And the answer is no, it only intersects once. So it passes the vertical line test. So this is a function. Now, how about let's do the others. This would be positive slope. Would positive slope pass the vertical line test? Yes, that's a function. Would zero slope pass the vertical line test? Yes, that's a function. How about a vertical line? Would a vertical line pass the vertical line test? No, it's going to intersect in an infinite number of places. So this is not a function. Now, how about a typical parabola? Does this pass the vertical line test? And it only intersects in one place. So yes, this is a function. Okay, let's go on. Now, we want to introduce here the symbolism of a function. And the symbolism of it is f of x. That is, we read it, the function of x is such that they give you the operation here. And you might say, ooh, this looks like y equals mx plus b. Looks like it's in slope-intercept. And the answer is yes. Again, why this section is included in Chapter 3. Because we can often substitute for the function symbol the letter y. Okay? So, how would you write this up? Well, a good suggestion is make a t-chart. And instead of putting a y here, we're going to put f of x. Now, our x value that they have here actually comes from this. So we're going to put in there a -3, a 2, and a 0. So if we put these values in, what will be our outcome here? And the same for this one. And for this one. And we'll let you fill in these charts and see what you get. Well, to help out a little bit, here we have a negative times a negative. We'll make this a positive. So the 3's cancel out. We have a positive 1 here. Minus 5 gives us a negative 4. Now here, when we put in the 2 there, this becomes a negative 2/3 minus 5, but I'm going to change that to a minus 15 over 3. 15 over 3 is 5, and a negative 5, but I've got common denominators now. So this is going to be a negative 17 thirds. I thought I'd help you with that one. And this one's easy. If x is a 0, this just becomes a negative. So I had miscopied, as I said. Have it correct now. Let's check this out. So negative 3 squared is going to be 9. 3 times 9 is 27. Now a negative times a negative is a positive. So this will be a positive 6 minus 2. So this will be a 4, and this becomes a 31. Now we have a positive 2 there, so let's check this out. This will be 2 squared is 4. 3 times 4 is 12. Minus 4 minus 2. So this adds up to a negative 6, and a positive 12 gives you a 6 here. Now this one is easy because you just put a 0 there. So 3 times 0 is 0. 2 times 0 is 0. This is just negative 2. All right, now for this one we have to put our values into what's between the absolute sign, and then whatever we get out of here becomes a positive. So let's work on that. So setting these up, we have the opposite of a negative. We'll make this a plus. So a negative 3 plus 3 is 0. Absolute value of 0 is 0. Now here we have a negative 3 and a negative 2. This will be a negative 5 that comes out of the absolute value as a positive 5. And here, if we put a 0 in there, negative 3 minus 0 is negative 3, but it comes out of there as a positive 3. Okay, so here are some examples of when we use function notation. We can substitute the f of x with a y. We can use a t-chart to put our values in, and then what will our function become, which is in a sense what is our y here. And a strategy for organizing your data and for writing them out. Now a little background on this. We have the function of x, in a sense, is 8. And our x value is 4. Well, remember we said we could write this as y, replacing the f of x with a y. Y is 8. So now they want us to put this into an ordered pair. Well, our y value we know is 8. What would our x value be? Again, looking here, it's going to be 4. So in converting from what we see here to, in a sense, function notation, we hopefully can come up with the ordered pair. So this, remember, is your x value. This whole thing is y equals 8. So we're substituting into an ordered pair. The y is 8 and the x is 4. Now I'm going to give you a few others here. Let me set it up. Something like this. When x is a negative 4, using this graph, what would y be? Well, we would go to 1, 2, 3, 4. That's where x is negative 4. 1, 2, 3, 4, 5. Y is 5. So this ordered pair here is negative 4, 5. This point right there. Now, if x is a negative 1, what would our y be? Well, we go where x is a negative 1. Y is going to be 0. That's your x-intercept, by the way. Now, how about if x, we don't know x, we know y is a negative 4, what would x be? Well, again, we go down negative 4, 1, 2, 3, 4. Our x is a positive 1. So writing these out, this is going to be a negative 1, 0, and this is going to be a 1, negative 4. So sometimes you might get something like this, where they give you one of the values and they want you to find the other. And I recall this next one that I'm going to set up in MATLAB, and I didn't see it in our mini lecture here, so I'll give it to you. And we're asked, what is x when y is 3 from this diagram? Well, where is y3? 1, 2, 3, right here. So what is this x going to be? 1, 2, 3, 4. This will be 4, 3. Because y is 3 there. 1, 2, 3, 4. Our x is 4. And there's another one here as well. So this is 1, 2, 3, 4. This will be a negative 4 and 3. So when y is 3, we have a value of x there and a value of x there. Now how about when y is 0? What will the x be? Well, when y is 0, there's an x value there and an x value there. So these are both x-intercepts, which would be a negative 2, 0, and this would be a positive 2, 0. Now we might have a value of x. They might tell you the x value. They'll want to know what the y is. But again, it's done in a similar way. Okay, this wraps it up. I will put the link to your chapter test review on this page, and hopefully you're getting ready for your test, keeping up with your practice and quiz me, and good luck.